we're gonna poke around on this and see if we can see what's going on the south side of this chip here.
You want to explain what all your cables are real quick?
Not too much going on here. The oscilloscope probe points there, and the ground is connected to this wire, which is connected to the ground of the whole circuit. Also connected to the ground is this little bus pirate probe, and that's going to ground on this audio jack back here. And the positive of that audio jack is going to this bus pirate probe, just so I can move around the tip of the input to that big speaker in the background here, so we can listen to individual I/O pins independently. And that's pretty much it. I also have a jumper handy for running the interface of the keyboard, turning on instruments and things like that.
Yep. So back when we did the oscilloscope probing, and we looked at the south side of the CPU, we noticed that, we had the demo running at that point in time, and we noticed that there were a lot of audio waveforms coming out of specific pins. And so we've chosen some pins to focus on, just to see what happens when you put an instrument through it, and what happens when you put a beat through it. What particular waveforms come out of that. So are we ready to try and select an instrument and then go from there?
Sure. I will need a little button for pushing.
Boom. Button.
Okay. I don't know if they can... Yeah, they can see it if I go here. So it's coming through the speaker that's hooked up to like the stock speaker from the keyboard, not this big one. We won't hear anything from the big one until we attach this wire to things. But I can now push this little button here as if I were playing the keyboard.
Okay. So let's look at south pin 1.
Okay, so you want to do an instrument select?
Yeah, well, we'll just start with piano. That's fine.
On south 1.
Yep.
And we're counting clockwise, so that would be here. And if I recall, these are at 5 volts.
Mm-hmm.
So it's going to be loud in the speaker. So I'm going to connect it, turn this down. Yeah.
Okay. And then south 2.
And then if I add that to the oscilloscope as well.
That's right.
Connect that up to the scope probe. Oh, we've got the little clippy thing for the scope. Where'd that go?
Clippy thing. I don't have a clippy thing. This thing?
Yes.
Oh.
Add that to the end of it. Then we can just clip onto it with the scope probe. Then when I play that,
Cool.
we can see it's just putting out a
square wave.
yeah.
Okay. And then S2.
Okay, here's the second one.
So same thing.
Another
S3.
square wave channel.
Yep.
It's a bit hard to tell which order these are in. I think that's 3.
Yep.
Which makes this one 4.
Yep. Nothing shows up.
Well, let's verify that it wasn't on there. Great. Yeah, nothing. A
Okay.
little bit of noise from the other I/O pins.
S11.
Nothing.
Okay. S13. Nothing. S18. Huh. So that one's supposed to be the PCM modulation.
Yeah, but it only does stuff when playing the demo
No?
and the drums.
No? That's not true. For the instruments it should be.
There.
Which one's that? S18? What happened to the...
Yeah, they're just reversed in order.
What happened to the garbledy modulation?
You want to hear it?
Yeah. Well, that, I mean, that's the
So
cool
we'll hook
part.
up the speaker here to that. That was a fairly quiet signal on the scope, so we'll turn the speaker back up. So that's some sort of modulation over the top of those square waves to get the, like the envelope maybe, of the piano. It changes over time. Yep.
That's cool. Alright, did we want to do another instrument or go straight to the beats, the rhythms?
Okay, so if we do a rhythm, I think that pretty much doesn't use these four at all. It just uses these two, like,
S11 and S13.
okay, so yellow is 11, 13 is white on these two. So I can use my button to stop the rhythm right here
Okay.
instead of poking it with wires. Which button is it?
Start, I think, is the first one. Or, if you wanted to use your wire, you could do U2 and U10.
U2 and U10. Let's see, 1, 2, 3, 4, 5, 6, 7, 8. Something in my eye, 1 second. Oh. 2 and 10.
Yep.
1, 2, 3, 4, 5, 6, 7, 8, 9, 10.
Alright, so this is rock.
This is the rock beat. You can tell because it rocks.
Alright, so let's,
And we're hearing it on the built-in speaker of the keyboard.
yep.
So I'll turn that down a little bit. And if we attach the scope to those two wires, what is it, 11 and 13?
Yep.
We'll see what's on them. Change it from 20 volts per division up to 2 volts so we can see. Even 1 volt, there we go. And so that we can see the pattern coming through.
Cool.
So we can see it. And now if we want to also listen to it, independently of the onboard speaker of the keyboard, we can hear what's going on. Fun. Okay, let's check out that next one. So we heard that, and you can tell it's just the higher frequency stuff of the drums. So the kick drum is definitely missing from that.
Okay, so let's take a look at Okay, let's take a look at S13.
So there it is on the scope, and we'll add it to the independent speaker here. So that's like the kick drum, right? And by looking at the various drum patterns, we discovered that it's the kick drum and the toms are on this, but it's just the CPU pin. So if we pick a rhythm that has toms in it, we'll hear what the toms sound like straight out of the CPU, and it's very interesting. Okay, how do I do...
Do I go for samba?
Sure.
Okay, so you'll want to do rhythm select, which is U1 and U11.
Okay, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11.
Yep.
Okay. And then which key do I want to press?
Samba, let me take a look. Let's go 9.
Okay, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Isn't that interesting? So that's what the toms sound like before they go through the onboard audio amplifier and filtering and mixing. So if I turn this down and turn up the samba pattern through the keyboard speaker, you can hear what those toms sound like after being mixed and filtered. That doo-doo. But that's what they sound like coming out of the CPU. They haven't been low pass filtered yet. Very interesting. They're very tonal.
And I think you actually were able to find different points too on the board.
Yeah, over here you can probe around in this area and you'll find each step of the mixing and filtering. So it'll sound different at different points along the audio chain. But we need to do the demo.
Oh, yeah, okay. Start stop demo is West 18 and U11.
I wonder what happens if I start the demo while the rhythm is still running. Alright, so 18.
Yep.
West side of the chip, and which one?
U11.
1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So the demo's running, and we're just listening to South 13 at the moment. Mm-hmm. If I turn up the speaker a little bit on the keyboard, right? So we're just getting one component of it. If I move my probes back over, oh, there's the toms. Get all this stuff unhooked here and hook up to that other line.
Ooh.
There it is on the scope. Now let's hook up our little speaker spy. Oh.
Man down, man down. Down again. It's kind of cool, actually.
Sounds very different before filtering. Alright, so now while we're in here, let's look for that PCM channel stuff. While this is still running.
S18.
Alright, now these are backwards. So So there is, I believe, 18. Okay, it's on the scope.
Holy Toledo.
So something odd going on there, but it's obviously all intentional. After it gets through the mixer, it sounds just fine, but here, it sounds really distorted and weird. Was there anything else on these audio pins to poke at?
I think we had like 2 data lines maybe, but they're just noise, really.
Yeah.
I don't know if they're that important, but yeah.
So, what is fun about this part of it is that when we do our big mod, we can opt to break these out on the case and have independent outputs of these different components for doing weird things with the keyboard. More circuit bending than our goal, which was just to MIDIfy it. But while we're in here, we can probably break some of these out so that we can add little, extra audio jacks in there for fun recording silliness.
You should show them one more line.
What's that?
S1 for the lead instrument.
Oh, during this
the demo?
thing? Can we not listen to it? Because it sounds terrible. But yeah, it's the square waves are still there. Let's pull up the square wave on the scope.
Ooh. That is like...
And it's a lot louder.
Slow it down.
Let's speed up the sampling here. You can see there's some possible pulse wave modulation happening in there. And let's give a listen, and I'll turn that down so it's not quite as
Oh no, I want to hear it
Yep.
on the cigar box thing.
Yeah, I'm gonna turn down that amplifier though. The amplifier in there is a Amplify Me from our Tindy store, by the way. But that's coming out of there at 5 volts peak to peak. So, way too hot for an Amplify Me.
It was cool.
Once it's mixed down, they're all the same level though. Or more appropriately mixed.
Yep.
Alright, so I think that kind of concludes the behind the scenes of figuring out where all of the things are on this. And to reiterate, if you're more into the circuit bending than the logical reverse engineering, you can do things like this. If I take my finger and lick it and just stick it here, Alright, I hope you guys enjoyed this little behind the scenes look. We'll see you guys later.
Ciao! ProtoSynth MIDI, ProtoSynth MIDI Lite, and all compatible modules are available for sale at tindy.com/stores/tymkrs, and in-depth technical information about this and all of our products are available at tymkrs.com.